lead. We make winners who lead.
Hello students, greetings from Learn to Lead Academy. So as we started with the current electricity, solving few problems in the previous video, we are going to solve some more questions based on current electricity in this video. So share this video with all your friends, those who are preparing for their competitive exam NEET. And definitely if you follow our video, we are going to give you more and more tips and tricks to crack the physics part in the NEET examination. Definitely you can score 170 plus in the upcoming NEET 2024 examination. All the best students. Now let us discuss few questions based on current electricity. See here, a copper wire of cross-sectional area they have given us 2 millimeters square. Okay, if you want to convert this into meter square, you should write it as 2 into 10 to the power minus 6 meter square. Right? And its resistivity is nothing but 1.7 into 10 to the power minus 8 ohm meter. It carries a current of 1 ampere. What is the electric field in the copper wire? They are asking what is the electric field. They have given the details like area and resistivity and current. With this we need to find the electric field in the copper wire. And we know that electric field is nothing but electric potential per unit length is electric field, and V is equal to IR according to the Ohm's law. So V is equal to I into R into L. See, we know the formula for I, but value for I, but we don't know the value for R and L, right? So for that, what we have to do is, you can write I into I by L. What is R? It is nothing but R is equal to rho L by A. So you can cancel L. So electric field is equal to I into rho by A. See, not only you should remember E is equal to, that is field is equal to voltage per unit length, you should also remember the other formula I is equal to E is equal to I rho by A. Okay, so what is the value of I? 1 ampere, and rho is nothing but 1.7 into 10 to the power minus 8 divided by area is 2.2 into 10 to the power minus 6. Okay, so if you solve this, you'll get 8.5 into 10 power minus 3 volt per meter as your answer. So it is very simple. So you should know how to get the electric field value when area, resistivity and current values are given. Simple formulas you are using. We are combining the formulas. 3 formulas we have to know to solve this problem. So electric field is equal to potential difference per unit length, and according to Ohm's law, V is equal to IR. This formula you should know, and R is equal to rho L by A. These 3 formulas we are combining to bring the answer for this question. Okay. So you should know how to use multiple formulas in a question. Then resistivity of the copper conductor is, they have given it as 1.7 into 10 to the power minus 8 ohm meter. And electric field is nothing but 100 volt per meter. Then what is the current density they are asking? So the formula for current density, J is equal to sigma into E. And sigma is nothing but conductivity, right? Sigma is equal to 1 by resistivity. So inverse of resistivity is nothing but conductivity. So 1 by 1.7 into 10 to the power minus 8 ohm meter. It is what? Sigma. Now my question is, what is the current density? Current density formula is sigma into electric field. What is sigma? We found it as 1 by 1.7 into 10 to the power minus 8 into what is the electric field? 100 volt per meter. So if you solve this, okay, you can rewrite this as 100 into 10 to the power 8 divided by 17 by 10. So 1000 into 10 to the power 8 divided by 17. So if you solve this, you'll get 6 into 10 to the power 9 ampere per meter square. So option A is your answer. So you should know the basic concept, what? J is equal to sigma into E, and sigma stands for conductivity. It is nothing but reciprocal of resistivity. Now, A charge of 4 coulomb is flowing through a copper wire of cross section 2 millimeters square in 2 seconds. If the conductivity of the copper is 6.25 into 10 power 7 Siemens per meter, the electric field in the copper. What is the electric field in the copper? Now, see here, a charge of 4 coulomb. So Q is equal to 4 coulomb is flowing through a copper wire of cross-sectional area 2 millimeter square. See, whenever you see millimeter square, you should try to convert it into meter square. 2 into 10 to the power 6 minus 6 meter square. Okay. Charge they are given as 4 coulomb. And time taken is 2 seconds. What is the conductivity? 6.25 into 10 to the power 7 Siemens per meter. And my question, what is electric field in the copper? Okay, what is electric field in the copper? So I know that current I is equal to charge by time taken. So what is the charge they have given? 4 by 2 time taken. So 2 ampere is the current we can find from this charge and time value. Okay, and then current density is nothing but charge per unit area is the current density, which is equal to sigma into E, and the formula. Okay, from this you can write out, if you fit both the values, so E is equal to I by A into sigma. What is I? 2 by area 2 into 10 to the power minus 6 and sigma 6.25 into 10 to the power 7. Okay, so if you solve this, you will get a value as what? 1.6 into 10 to the power minus 2 Newton per coulomb. So how will you cancel this part? 2 by 2 into 10 to the power minus 6 into 6.25 into 10 to the power 7. 2 you can cancel. And at the end you will get 6.25 into 10. And you should know that 1 by 2 is 50. It is nothing but 0.5. And 1 by 4 is nothing but 0.25. 1 by 8 is nothing but 0.125. And 1 by 16 is nothing but 0.0625. See, 0.0625 you can write it as 6.25 into 10 to the power minus 2. Already 10, just added 10 power minus 2. Okay. So, from this, for 6.25, okay, so 6.25, 1 by 1 by 60. So, you solve this, you will get 1.6 into 10 to the power minus 2 Newton per coulomb as your answer. Next. A potential difference V is applied to a copper wire of length L and diameter D. If V is doubled, what will be the drift velocity? Okay, V is doubled, what will be the drift velocity is my question. So what is the formula for drift velocity? So drift velocity is equal to charge E into capital E divided by M into tau. So E by M into tau into V by L. For electric field, you can write it as V by L as formula. So drift velocity is directly proportional to potential. Okay, now which is doubled? The potential difference V is applied to the copper wire of length L and diameter D. If V is doubled, that is, if potential difference is doubled, drift velocity will also be doubled. Drift velocity is also doubled. Next. A current I is flowing through the wire of diameter D having drift velocity of electrons v d. What will be the new drift velocity when diameter of the wire is made d by 4? So current and drift velocity relation you should know, NAE into VD. NAE into VD. And drift velocity is inversely proportional to area. If diameter of the wire is d by 4 and area will become what? d by a by 16. So new drift velocity will be 16 times of VD. New drift velocity will be 16 times of VD. Okay. So what are the concepts we have seen so far? What are the formulas we should know? So first, based on current electricity, we should know a basic formula. Current I is equal to charge by time taken, and charge Q is equal to NE. And according to Ohm's law, V is equal to IR, and R is equal to rho L by A, and electric field is equal to potential difference per unit length. Okay, and then current density J is equal to sigma into E, and sigma stands for conductivity. Okay, and sigma is equal to 1 by rho is nothing but resistivity. Okay, and then current density we have seen. And next, we should know drift velocity formula. Drift velocity is equal to E into capital E divided by M into tau. Okay, you should also know that drift velocity is directly proportional to the potential difference applied, and drift velocity is inversely proportional to its area. Okay, these are the concepts you should remember. These are the formulas you should remember under current electricity. All the best, students. So I hope this video was very useful. Definitely we are going to solve many more questions based on current electricity. Don't forget to subscribe our channel and also share this videos with all your friends. Thank you guys.
Learn to lead. We make winners who lead.